In this video, we're going to see how to perform the pivot operation on this tableau, which is the initial tableau for this standard maximum problem given above. Now, to carry out the pivot operation, we need to locate the pivot element. To locate the pivot element, we need to determine a pivot column and a pivot row. To find the pivot column, we look at the following four numbers. These four numbers are called indicators. I'd like you to notice that the number at the bottom of the Z column and the number at the bottom of the right-hand side column, those two numbers are not indicators. The pivot column is determined by the most negative indicator, which in this case is -6. Now, if there's a tie for most negative indicator, you can break the tie by picking either column. In this case, there is no tie. The next step to determine the pivot element is to locate the pivot row. And to do that, we look at the smallest positive ratio, where we determine the ratios by looking at the right-hand side over its corresponding entry in the pivot column. So for the first row, we have 6 over 1, which is 6. And for the second row, we have 9 over 2, which is 4.5. 4.5 is smaller than 6, so the pivot row is given by the second row here. The number that's in the intersection of the pivot column with the pivot row is called the pivot element. In this case, it's this circle 2. The next step is to make the pivot element a 1 by multiplying the row that it occurs in by an appropriate non-zero constant. We can do this by taking row 2 and replacing it by a half of row 2. So we're dividing row 2 by 2 here. And if we do this operation, so we take 2 over 2, we get 1. 1 over 2, we get 1 half. 0 over 2, we get 0. 1 over 2, we get 1 half. 0 over 2, we get 0. And 9 over 2, we get 9 halves. And this gives us a new tableau. The next step is to use the pivot to make the other entries that appear in the pivot column 0. Now we can do this by taking row 1 and replacing it by negative row 2 plus row 1, and taking row 3 and replacing it by 6 row 2 plus row 3. And if we do that, we have negative 1 plus 1 is 0, negative a half plus 1 is a half, negative 0 plus 1 is 1, negative a half plus 0 is negative 1 half, negative 0 plus 0 is 0, negative 9 halves plus 6 is 3 halves, 6 plus negative 6 is 0, 6 times 1 half is 3, 3 plus negative 5 is negative 2, 6 times 0 is 0, plus 0 is 0, 6 times 1 half is 3, plus 0 is 3, 6 times 0 is 0, plus 1 is 1, and 6 times 9 halves is 27. So now we've just carried out one pivot process, and we have the updated tableau given by this tableau here. Now the idea of the simplex method is to continue pivoting until you can't pivot anymore.